So what exactly is a Heaviside unit step function? Heaviside unit step function is denoted by h of t, and it is nothing but the unit step function that we have seen. That means h of t is equal to u of t. If you want to see it in the graph, it can be seen as the function that gives you value 1 starting from t equal to 0 and the value 0 before time t equal to 0. So what exactly is the main difference between a unit step function and a Heaviside unit step function? Actually nothing. So basically the Heaviside unit step function is used in conjunction to describe different other functions. So now particular h of t minus a will be similar to what we call u of t minus a. Alright. So basically this a describes the shifting in the function. Now when you have some system, say system A, and if you want to give the input f of t to this particular system to get an output y of t, this function f of t may be assumed to be something like this. Function will not always be ideal and it will not always what you want to give. Let us say if I want the input from this particular point and afterwards. Alright. So what I will do is I will multiply this function f of t by u of t minus a, where a is this particular value from which I want to take the values ahead for f of t. So this is how you can cut a particular part of the function and give this as an input to system so that you can decide which part of the function f of t you want to give input to. And how is it decided? You just switch on the button, or you just switch on the input when you want to give at particular time frame. Most of the times you will find functions will be in conjunction with u of t. This only means that you're taking value of f of t from t is equal to 0, because u of t gives you the value 1 only after t equal to 0. So if you multiply by 1 to this function wouldn't change, but you will have to multiply by 0 for time t less than 0. So f of t will not exist for t less than 0. It will exist for t greater than 0. Alright. So this is how a Heaviside function is used in conjunction with the function. Let us just quickly see the example. So let us say this is my f of t, which is actually spanning for t less than 0 as well. It has some amplitude for t less than 0. What will happen if I shift this function by a? F of t minus a, this will look like this. The origin will shift to a. Alright, this is my f of t minus a. All the remaining graph will remain same. Now if I multiply f of t minus a with u of t, now I am multiplying this function by u of t. So I have values, non-zero values for t greater than or equal to 0. So I will take values from this particular domain. So this is the graph that remains, and everything that is less than t equal to 0 is gone to 0. Alright. So there is no graph behind t less than 0. What if I multiply f of t minus a by u of t minus a? So how will it be done? U of t minus a will just look like something like this. At the same time, even f of t is starting. Alright. So all the values that are less than t less than a, that are less than a, will be 0, and hence even this part will be nullified in this particular graph, and only this particular part of the graph will exist. This is how you can choose different kind of functions to give input to systems, and mathematically you can represent them like this. You have to decide which particular technique you have to use a particular input. You can easily calculate the Laplace transform of such functions, f of t minus a into u of t minus a. The only thing that you need to know is the Laplace transform of original function f of t. Let us say it is f of s. Then The Laplace transform can be given by e raised to minus as into f of s. This is how simply you use the Heaviside unit step function in conjunction with different functions, and then you can simply calculate the Laplace transform whenever needed by using this particular shifting property. Alright, I hope you have understood what exactly is the difference and the similarities between Heaviside unit step function and a simple unit step function. I will meet you whenever you call me back. Thank you so much.